Okay, we're back and we're going to do the next section, chapter 12.2. And this is referred to as the power rule. And it's kind of like the chain rule is what you're going to think of it as. But first, we need to talk about differentials. That's an R. And the differentials are like the dx's that we saw in the integration functions. And recall that f of x typically gives us our y coordinate, right? And if I want to take the derivative of f of x, one way to write the derivative, d by dx. But I got to do that to both sides of the equation. If I take the derivative of this side, I have to take the derivative of that side. We'll get the same thing. And we know this as f prime, right? You're probably thinking, okay, Mark, why do I care? You will. And just for fun, because it will be fun, let's solve for dy. So I'm going to multiply both sides by dx. Think of it like a variable. And these are going to cancel. And you'll end up with dy equals f prime of x dx. True? Absolutely true. This thing is the differential for y, and this thing is the differential for x. And those are going to be important things that we're going to use for this next section. So for example, let me clear the screen. If y equals 4x squared plus 6, let's say, and I want to take the derivative of both sides. So if I differentiate it, this is like dy is going to become the derivative of this times dx, because that's what we had, right? The differential of y is equal to the derivative of the function times dx. So the differential of y is going to be the derivative of this function. 2 times 4 is 8 times dx. So basically, wherever you see an x in this in the function, it's going to end up with a differential next to it. For example, y equals 4x squared minus 7x plus 2. And we want to take the derivative of this and show it as differentials. So the derivative of this is going to be, let's see, the derivative of that thing is going to be 8x squared, 8x minus 7 dx, right? The derivative of the function times dx gives me dy, the differential for y. And this is going to be critical for using the power rule, being able to do this, okay? So you need to trust me. This is important. I know you don't trust me. I don't blame you. I've done some shady stuff in the past, but this is important. Okay, so now, also, let us recall f of x equals 4x squared plus 6x minus 7 cubed. And we want to take the derivative of this. Well, we use the power rule. We say the derivative, what happened? Stupid side buttons. So that'd be 3 times 4x squared plus 6x minus 7. I hope you all remember that. Times 3 minus 1 is 2. Times the derivative of the goop inside, which would be 8x squared oops, that is incorrect. 8x, I almost caught it, plus 6, right? That's the derivative of the goop inside. Hello, Kitty. She wants some attention. Okay, so now that you have recalled that, let's look at the power rule. Power rule says if I take the integral of a function, u of x raised to an exponent times du, then this is going to be u to the n plus 1 over n plus 1. No big surprise there. Except u could be a function just like this was a function that we were operating on. And so we have to make sure we have the right differential on the end so that we can do it. Now this is synonymous with x to the n dx, right? X to the n plus 1 over n plus 1 plus c. Those are equivalent statements. One of them assumes this is a function. The other one is just a variable x. Okay, so let's try this rule, and I'm going to write the rule up here so I don't lose it. Integral of u of x to the n du equals u to the n plus 1 over n plus 1. And the important thing is knowing what u is. Okay, so let's say we have the integral of 3x squared plus 4 to the 5th power times 6x dx. Holy crap, this is like a product rule, and you got this power rule thing here, and this is a function inside another function, and you don't want to multiply this thing out to the 5th power because then it becomes massive, and it's like, holy crap, what the hell are we doing? So when I see this, a function raised to a power, I know this is a power rule problem. And I know in this form, u is most likely going to be that function inside the parentheses. So I'm going to let u equal 3x squared plus 4. Now, many of you are going to say, really, I remember doing this in geometry in high school, and really got to do the let and give in and all that kind of junk. Well, yeah, you do, because this is going to keep you from making mistakes. So write it out this way. Trust me. I know I've lied to you some, but not as much as you'd think. So do this, and now let's take the derivative. So du is going to be the derivative of this thing times dx. What's the derivative of this? Well, it's going to be the 2 will come out front. 6x, the derivative of 4 is 0, times dx. Now we look, do we have this in the problem up above? And the answer is yes, we do. So I can rewrite this integral as integral of u to the 5th power, because here's my u, which is right here, times, and look at that, 6x dx is equal to du. Holy crap. We have it in the same form as the equation up here. So I can rewrite this as u to the n is 5. 5 plus 1, everybody say it with me, 6, right? So this is the integral of that thing. And now we go back to u and we do a little substitution action. So this will be 3x squared plus 4 to the 6th over 6 plus c. So this is the integral of this thing up here. This is how we use the power rule, okay? Let's take a break here and we'll come back and we'll do some more examples. Sadly, we got a lot of examples to do. Bye-bye.